Hello everyone, I hope you guys are doing good. And today we'll be discussing another problem of our Blind 75 series. And the problem of the day is longest common subsequence. So here we have been given two strings, text1 and text2, and we have to return their longest common subsequence. If there is no common subsequence, we just have to return a zero. To understand, a subsequence of a string is a new string generated from the original string with some characters, can be none, deleted without changing the relative order of the remaining characters. A good example has been given over here, where it has been mentioned that ACE is a subsequence of A, B, C, D, E, even if we do not have P and D in our first string, it's still a valid subsequence as A is followed by C is followed by E, and the order is maintained in both of the strings. So let's start our solution. To address this problem, we have to address some base cases. Let's say our strings are T1 and T2. The first base case is if any of T1 or T2 is empty, any of T1 or T2 is empty, the longest subsequence that we can have is of length 0. So we'll just return 0. Other base cases is when we are traversing, let's say, for example, we have been given a T1 equals to A, X, Z, and we have a T2 that's equal to B, A, C. And if we are looking at this string and we know that the last characters of both the strings match, then we just have to return 1 plus our recursive function of finding the longest solution or the longest common subsequence of AX and BA. This is first case, this is the second case, and the third case would be if this case would be called if last element matches. And the final case would be what if the last element does not match? What if we are at position I equals to 1? And we can easily see that X and A, they do not match. Then what we can check is we have to return the max of either we'll check just A and BA, or we'll check AX and B, just to be sure if we have any common element not including the elements at index I equal to 1 and divide it into two different cases. So for this recursive approach, we generate our dynamic programming approach that would be by creating a DP grid. And even if you did not understand it till now, I'm pretty sure that you would understand it after just going through this example. We'll keep the same example, let's say A, X, Z, B, A, C. So as we can see over here, we have initialized our DP grid as none times n plus 1 for I in range m plus 1. So here we are considering our text2 over here or in columns and text 1 over here or row wise. So we know if either T1 is null or either T2 is null, the longest common subsequence we can return will be of length 0. This was our first case. Our second case was, what if our last elements, let's say when we are at this position, what if the last element over here, that is BA, and the last element of T1 would be A for this case, A and BA. The last element matches. So if the last element matches, what we needed to do is just return 1 plus the value of the string T1 without considering A and T2 without considering A. We'll just remove both of the string and we'll check if the remaining parts of both the string, if they have anything in common or not. So to check that, we'll just look up to this position. And as we can see, we have nothing over here. So we'll just append 1. For cases like when we do not have anything in common, let's say for this case, B and A, we know there's nothing in common. So we'll just remove B ones and check if there's common in A and 0. And we'll remove A ones and check if there's something common with B and an empty substring. And we know there's nothing in common. So we'll just return the maximum of both these over here and return a 0. After that, we'll just move forward row by row and fill up each of our values, which will go as, I will recommend you to fill up these values on your own, and you will definitely get the crux of this problem. And I know it may be a little bit difficult to understand, but it would make sense when you try it by your own. So when we come over here, the string at this position would be BAZ, and string over here would be only A. So Z and A do not match. So what we'll do is we'll just append the maximum of these two values. So 1. Similarly, B and X do not match. So the maximum of these two positions. So it would be 0. A and X does not match. So the maximum of these two, that would be 1. Similarly, Z and X do not match. So the maximum of these two. Similarly, B and Z do not match. So 0. A and Z do not match. So maximum of these two. Then Z and Z matches. So as we can see, Z and Z matches. Now we'll look if AX and BA have something in common. So for that, we'll just look into row -1, column -1. And it says, yes, there is one element that's matching. So we'll just append 1 to it, and it would be 1 plus 1 equals to 2. And we'll just return dpn, n as our answer.